What is going on, guys? Vlad with eenthusiast.com here, and today we're going to be doing something a little bit different. So as you can probably already tell, I have a very large box which is filled with electronics sitting on my desk. So we're going to be unboxing all of these pieces and then going over the basic setup and configuration of these modules. But before we begin, I just want to give you a really brief background on where this box actually came from and where what it contains. So essentially on my channel, as you've seen over the years, I've done quite a few tutorials on embedded systems with a big preference on the Arduino just because it's a very widely used platform. However, as my day job, I actually program control systems, or what are called programmable logic controllers, which you've seen in some of my latest videos. And these controllers essentially control different manufacturing processes and automate, large-scale industrial manufacturing operations. Now, a passion of mine has always been to kind of combine the two and allow some of the individuals who are trying to bridge that gap to kind of get to that knowledge base a little bit quicker. Now, the biggest problem or hurdle with learning those systems which are applied in manufacturing is the fact that they are extremely expensive. Some of the controllers that I work with can go up to $10,000 or even $20,000. Now, Automation Direct is a very cool company which actually has different lines of PLCs. So just like many others, however, they do have a very affordable line which is called the CLICK. And they've been essentially gracious enough to send me a couple of these PLCs so that I could demonstrate them, but also kind of play with them, see what kind of different projects we can come up with. And also I'm going to be releasing a series of projects which are going to be interfacing some of these PLCs to the Arduino. But without any further delay, let's get a knife and we will start unboxing and see what we got inside of our box. It's actually a surprise for me as well because I haven't actually opened it yet. As you can see, the seal is breaking right now. So we should be getting a couple of pieces. Let's open it up and see what we got. Some brown paper. All right, cool. So the first item here, we have the Automation Direct model C001AC. So we are going to be opening this as well. And I'm just going to unbox box by box. Make it really nice and interesting for you. So in the first box, let's open this up, pull it out. We have, I believe this is one of our clicks. Let's see here. I just want to remove the plastic really well. So actually this is a power supply. So they've also provided me with a power supply, which essentially is 110 volts down to 24 volts. I'm going to be showing each one of these individual on my desk as well, so you can see and get a better view at this. But essentially we have a power supply. And all of these modules are very cool because they essentially sit on what's called DIN rails, for those of you who are not familiar with the manufacturing standards. And they essentially plug and play into a control panel, and at that point you can essentially interface all of them. I'm just going to remove some of the clutter off the desk, and we're going to get into the next module. All right, cool. So it looks like a second power supply. Sweet. So we do have a couple of controllers, therefore we will need two power supplies. Let's see, what else do we have here. So here I have a EA3T4CL. So this is actually a graphic display panel, or what they're usually called in manufacturing an HMI, or a human machine interface. Let's open the seal on this and then we can take a look at what that looks like. And once again, I will be doing kind of a on the desk display as well. So we do get a quick start guide with all the instructions that you might need, all the references, all the software downloads, so on and so forth. So here's the HMI. So it's essentially, an HMI is essentially a small screen for those of you, like I've said, who are not familiar with industrial manufacturing. So this is what it looks like. It's just a little panel, and we will be looking at some development on that as well. And it looks like it has a serial port as well as an EtherNet port, which communicates with your PLC systems directly. We'll place that on the side for now. Just want to declutter some of my desk. And let's proceed further. So here I believe we have, let's see, so this is another power supply, DIN rail mounted, a slightly larger power supply. going to take that out on my own, but here are the most interesting components. So I have two more boxes left inside of here. One of them should be the analog controller and the other one's going to be digital. So let's take a look. So this is very exciting for me because, like I've said, this is one of the platforms of choice that I have for those who are trying to move into industrial automation, just because the cost is just so affordable and you can do pretty much what you would do with some of the more advanced system. So here's the first PLC. As you can see on the front plate, we have our Ethernet port as well as the RS-232 and 485 ports. So very, very cool. You can definitely, put it in run and stop modes, but we'll discuss that in a bit. So let's put that on the desk as well. So we have the PLC, the first PLC here, and then we have the second one. So let's open that as well. And there's not going to be, I guess, a huge physical apparent change on the PLCs as far as you might be able or might not be able to tell, but essentially there are two different PLCs which have, so one of them will have analog ports, and we'll demonstrate that in just a second. So here's the second PLC, and that's all we got here. So very exciting, very cool stuff. We're going to be doing a lot of really awesome projects with these controllers, and let's essentially take a look at them individually a bit closer. All right, so this is what we had in the package. So essentially two of these are just power supplies. Really quickly, as you can tell through this terminal, it converts the line and neutral, which is going to be 110 to 24 volts. And this is the standard for manufacturing. Most of the equipment nowadays runs on 24 volts, although you still see some 110. And depending on the location that you are in, it may be 220. So I'm going to put those away for now. We're going to look at the PLCs, which are actually the most exciting part of this whole package. So here I have two clicks. And as you will see, I guess it's not immediately noticeable, but you will see there is a difference from the part numbers. So the one on the left side is going to be the C011DRE-D, and then the one on the right is going to be the C012DD2E-D. And the difference, as I've kind of alluded to before, is essentially that this one has only discrete inputs and outputs, whereas this one has analog capabilities as well. So looking a bit closer, you will see that there's a couple of things located on a typical PLC, and this is features that are common amongst many of them, not just the clicks from Automation Direct, but some of the other brands as well. So first of all, you have this essentially switch, which allows the PLC to be in stop mode or in run. So typically before you turn on your control system, you want to program something, it's going to be in stop. We'll figure out if that's the case for the clicks. Then of course you get LED indicators for the power, the run, and if there is an error which occurred on the PLC, and this could be a fatal error, or it could be, I guess, a software error. So we'll take a look at that as well. You do have two or three different ports for different communication protocols. So the most common one that I'm using nowadays is, of course, EtherNet. So some of their, I guess, even cheaper models do not have Ethernet, but this one does. So it's really convenient. You can program that with most laptops that you have access to nowadays. You obviously have RS-232 down here, as well as RS-485. We'll also be talking about those connections as well, because we can do some really cool communications to the Arduino and some other devices and peripherals. Now, for the outputs and inputs, you'll have this very long, I guess, screw terminal that you have right here on the side, and you'll have an indication. So all of these terminals are labeled and as well as what they do, and there's going to be LEDs on this side. I don't know if it's easy to see or not, but essentially on this particular PLC you will have 8 discrete inputs, so all of those are going to be 24. Of course, it's going to be high when it's 24 and then low when it's 0. And then you will have 6 discrete outputs, which are going to be labeled Y1 through Y6. And you'll have comments, so C3 and C4 are going to be the comments for those outputs. Now on this side, you'll see that the labeling is going to be slightly different. However, they do keep the same system, so it's not too difficult to recognize what they are. So the X's are always going to be discrete inputs. So here you have 4 discrete inputs, and then you have essentially four discrete outputs. So these are going to be Y1 through Y4. Then at the bottom here, you're also going to see some analog stuff. So here you can have 2 or 4 analog inputs. And then, so those are going to be AD1, AD1V, AD1I, AD2V, and AD2I. So we'll get into those standards a bit later, but just in case you're curious, in manufacturing, you can have 2 different schemes when it comes to analog inputs. So those can be either 0 to 10 or sometimes minus 10 to 10 volts, and then you have 4 to 20 milliamperes. So that's why you have the voltage and the current. Then you have the digital analog outputs. So here you have two distinct outputs that you can set up and use on your PLC side. And it is very convenient. However, I guess it really depends on your application if you do need to control some analog devices. And so last device that we have here, let's move these PLCs to the side. And the last device that we have is an HMI screen. So like I've mentioned, an HMI is essentially a display. It has its own processor, I believe. The higher end ones do run Windows essentially embedded on themselves, but this one we're going to be looking at how to program it, and you should be able to essentially control your PLCs through so here you have a serial port, but you can also use of course Ethernet, so it makes it really easy to set up and get going with a very nice application. All right, so let's go over the hardware connections. So of course we have our power supply as well as the PLC right here. So what I'm going to do first of all is feed 110 volts to our power supply. So that's really easy to see. You have your ground, your line, as well as your neutral. So I'm going to start off with the ground. So all I need to do is essentially insert this wire into the terminal and then tighten that particular screw. And I'm just going to move the PLC over to make the process a little bit easier. So I'm going to tighten that screw. I'm going to then land the neutral as well as my phase. So the neutral goes in right there. I'm going to tighten that up. Make sure it doesn't come out and cause a spark or any issues. And lastly, it's the neutral. So all those are nice and secure. I'm going to put back the cover for now, at least for all of those terminals that I've connected. And then we need to connect a 24 volts output, which is located right here, to our PLC. So if I put the PLC on its side, you will notice that that's where the 24 volts needs to come in. It's kind of nice and faint, but it's 24 volts, then the 0 volts, as well as the ground all the way at the bottom. And these terminals are insertable, so you can just pull them out and really easily land your wires onto them. So what I'm going to do is essentially take my wire and I'm going to land that in the terminal strip, tighten all the screws, make sure that we get the 0 volts as well. I'm going to put that back into the PLC and reconnect both of those cables to the power supply 0 and 24 volts. So I'm going to put that protective cover all the way back. And then what's really neat about these PLCs, I haven't noticed that at the beginning, but once you insert them into each other, then you can use these latches on top. So as you can see, there's kind of a lock and unlock. It's, again, just typed in the plastic, but if you slide that back, you have the same latch at the bottom. And now you've created essentially this very neat little block, which can be used inside of a panel through the DIN rail on the back, or it can be, I guess, in a just desk environment. I can program it on my table, but it makes it really nice and neat. So I powered it on. As you can see, we do have power on the PLC side, so everything's good. There's no errors. Of course, it's currently stopped. It doesn't have a program yet, so we're not going to switch it on to run, but I will plug in the Ethernet cable, which is what I'm going to need in order to set the IP address and start programming this PLC. But let's turn our attention to the software side now. Alright, so on the software side, the CLICK line actually has a free package which you can download directly from the Automation Direct website, and I will be posting a link below in the description. So what I have here is essentially a new project which is requesting me to select the CPU type, and remember that's located in the top right corner of the module that you're using. So in my case, it's going to be the C011DRE-D. So I'm going to select that, and it's going to show me some details. So the inputs are going to be from 1 through 8. The inputs are going to be configurable from sink and source. That's a topic for a different video. You are going to also see 6 different outputs as we discussed before. The outputs are going to be relay based, so essentially they're going to connect this common, which is C3 or C4, to either of the outputs. And then we have communication over RS485. And of course, standard here also 232 as well as Ethernet, through which we are currently plugged in. So I'm going to hit OK, and here is the interface for ladder logic. So it's slightly different than what I'm used to, because typically I'd work in RS Logics, which is the Allen Bradley type of PLCs. But we're going to be essentially creating a very simple program, which is going to be blinking some of our outputs on a timer. All right, so like I've mentioned before, our goal is going to be to essentially blink one of the outputs as the hello world introduction into PLCs. So what I'm going to do here is essentially create 2 different timers. So I'm going to go to instruction timer, add the first one. So here timers are essentially labeled T1 through all the way. There's, I guess, 500 of them in this list, but I'm going to start with T1. The set point is going to be in milliseconds. We can set it to 1 second, but let's just put that as 1000 milliseconds, which is exactly the same. And then I'm going to need a T off timer essentially. And this is going to be, once again, a timer. And this time you can just type that in, T2, and it's going to be 1 second as well. I'm going to use an on delay just because it's simpler and it's just very convenient, and you know exactly what's going on in your program. So in terms of logic, I can also add coils. So I'm going to go here. So these are essentially XICs. Sorry, the contacts are XICs and XIOs that you would see in other programming software. So here we're going to use timer 1. So when the timer 1 is done, so that's going to be, let's see here. So here we'll click on T, and we have T1, and we're going to hit it OK. Yes. So when T1 is done, our T2 is going to begin, and that's exactly when our LED or output is going to be energized. So I can just, let me see if I can copy this and I can paste this here. Perfect, so that works. And I will also paste that up here, except I'm going to, so this is going to be an XIO, so that's going to be different. Let's see here. So I'm going to put in an instruction. Once again, it's going to be a contact, but it's going to be normally closed in this case. And this is going to be T2. So T1 is going to be counting until T2 starts to count, and until it's done, then it's going to reset. So while T1 is counting, that's when we want to energize one of our outputs. So I'm going to select instruction, go into coil, and this is out, which is essentially comparable to an OTE. If I click on these 3 dots, then I should be able to select the first output, click yes, hit OK. And then last but not least, I've learned this through experimentation. What you need is essentially a AND function. So we're going to drag that out here. No, we do not need a next. We do need an AND. So instruction, program control, hit AND. And that should be it. What we can do now is go into program and then do a syntax check to make sure that we get 0 errors and 0 warnings here at the bottom. Now, what we need to do is, and what I've done a little bit before, so I'll show you again. So PLC, and then you hit connect. And the PLC which it's going to connect to is going to be found on the network. So if I go and select my Ethernet card on my computer, I should be able to find this PLC. Let's see if it scans the LAN automatically, but I was able to see it recently. So this should be, this actually is a different, so it's not going to be wireless, sorry, it's going to be the hardwired connection, which is going to be on the correct LAN. So that's actually the IP that I gave to the PLC, and you can do that by clicking this edit button, and you can set your own IP address for the PLC on your network. That's looking good. We'll hit connect, and then we're not going to read the project from the PLC because we want to download our own to the PLC. So once we're, I guess, connected like so, we can hit this write project into PLC, and then this will first of all ask us to save the project. As you can see, I've practiced with one just before making this video. So everything is going to be good. The PLC is good, and we can use the setup. We'll hit yes. And then this essentially shows us the memory, how much free space we have. And as you can see, it's quite a bit of free space. So of course our program is really small, but as it evolves, it will take up more and more time. And we'll hit this OK button, and this will transfer all of our programming onto the PLC side. So the transfer is complete. However, the PLC is still in, so it's technically in run mode, but this will not let us put it in run mode until the switch on the actual PLC is switched to run. So let's try that here. We'll click on cancel, and then I'm going to flip the switch on the PLC to run. And what you will notice is that, first of all, there's this clicking sound, but also if you look at the LED, which is going to be for the output 1, it is now blinking. So our PLC is pretty much communicating. I'm not sure why we got this lost communications error, but the PLC did definitely get the program, and it's running the software right now. I believe actually if we go back into this offline mode, let's see here if we, no, we're still connected. So if we run the PLC in run mode, then it's of course running our program, which is the 2 timers toggling this output Y1. So this is pretty much the hello world of PLCs. We're going to be doing quite a bit of programming with these along with microcontrollers, so stay tuned. If you have any questions on PLCs, if you need any help on programming your software, do let me know in the comments section down below. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely the world to me. And if you have any suggestions for the channel, what kind of hardware, software I should be covering, then make sure to leave that down there as well. See you next time. Take care. Bye.